Hi girls, today we're looking at the lactic acid system, which is the second of the anaerobic energy systems. Our success criteria for today: you will have achieved success in this lesson if you can identify the characteristics of the lactic acid system, identify which sports and or activities use this energy system, and obviously importantly, apply the energy system to a touch football context. So the lactic acid system is an anaerobic method of resynthesizing ATP using glycogen or glucose as the fuel. So the creatine phosphate system used creatine phosphate as the fuel. The lactic acid system uses glycogen or glucose from carbohydrates as the fuel. Okay, this system takes over when CP stores become exhausted, and it supplies the ATP our muscles need to keep exercising, particularly when exercising at a high intensity. The following video will explain that in a little bit more depth. It does revise the creatine phosphate system or the ATP system a little bit before tapping into the lactic acid system. So a little bit of revision there for you girls.
While ATP is the fuel that supplies the energy for muscles to work, unlike some other types of fuel you might be familiar with, it's not a case of simply filling up the body's tank with ATP and off we go. In fact, the body has three different energy systems, and they all work together to enable our muscles to contract and allow us to perform an incredible range of movements. The first two energy systems we'll examine are called anaerobic energy systems. That is, they function without oxygen. Firstly, the ATP-PC system. PC stands for phosphocreatine. Let's look more closely at an ATP molecule. Its molecular diagram looks like this. When the energy from an ATP molecule is released, one of the phosphate groups, consisting of one phosphorus atom and three oxygens, splits away. The remaining molecule is known as ADP, or adenosine diphosphate. Its molecular diagram looks like this. But when PC, or phosphocreatine, which is also found in muscle cells, reacts with ADP, it donates a phosphate group to the ADP molecule, and an ATP molecule is again formed. When PC gives off its phosphate group, a molecule known as creatine is left. For this reaction to take place, an enzyme called creatine kinase must be present. This series of reactions is the basis of the ATP-PC energy system. ATP synthesizes to ADP and resynthesizes to ATP with the help of PC molecules and the enzyme. These reactions take place very quickly inside the muscles, and because PC is stored in the muscles, it is the first energy system used during high-intensity physical activity. The muscles only store about 10 seconds worth of PC, so any physical activity that involves quick, short bursts of energy makes heavy use of the ATP-PC system. When the 10 seconds worth of PC is used up, muscles start relying on the second anaerobic energy system for the bulk of their energy. This second anaerobic energy system is known as the lactic acid system. It works by synthesizing new ATP molecules from glycogen, which is the stored form of sugar in our bodies. The reaction is known as glycolysis, and because it doesn't involve oxygen, it's called anaerobic glycolysis. Through a complex series of reactions, glycogen breaks down into ATP and lactic acid. This anaerobic glycolysis occurs when muscles are working above their lactate threshold, something we'll look at in more detail later in the program. As lactic acid builds up in our muscles, they begin to hurt and feel stiff, and this serves as a signal that our muscles are wanting a rest.
Okay, so just a reminder that anaerobic glycolysis is the conversion of glucose to lactic acid, and obviously it's in the absence of oxygen, and the lactic acid system resynthesizes ATP using glycogen or glucose as the fuel. So really important to take away those couple of points. And obviously it supplies the ATP our muscles need when exercising, still at a high intensity, just like the creatine phosphate system. So just a bit of a repeat from the video. We did look at something similar in the creatine phosphate lecture in terms of the diagram and the breakdown of ATP. So obviously the phosphate breaks off to form the ATP. Now you know we have to resynthesize that ATP after it's been used to the working muscles, and we do that through glycogen, okay, to bring back that P onto the ATP, okay, and again it's a revolving cycle. So glycogen is a stored form of carbohydrates, is used as the energy source to resynthesize ATP. Now, as I've said before, this is a more complex method of ATP production. It uses glycogen, the stored form of carbs, as a source, and it can actually involve up to 10 to 12 chemical reactions. So it is a little bit more complex than the creatine phosphate system. So the video did explain this diagram. It's just a bit more simplistic in terms of you being able to understand it. So as the video said, the use of glycogen as the energy source in the absence of oxygen is known as anaerobic glycolysis, and it involves the conversion of glycogen to glucose, which is then converted to pyruvic acid, okay? And the byproduct of that is lactic acid. Now, the energy released at this point here can produce actually approximately 1 to 3 ATP molecules for each glucose molecule. All right, so a little bit more than the creatine phosphate system. Remember, that was 1 for 1. Okay, now it's 1 to 3, and hence this system can last a little bit longer than the creatine phosphate system. In the absence of oxygen, the pyruvic acid is converted to lactic acid. Now, that acid is a molecule produced by the breakdown of glucose. Okay, we know, again, repeating, the byproduct of all this, the conversion of glucose into pyruvic acid, is lactic acid. Okay, so for every molecule of glycogen are broken down, 1 to 3 molecules of ATP are resynthesized. That's really, really important to get down. And like I said, that's why this system can last a little bit longer than the creatine phosphate system. So the video spoke a lot about the lactic acid system and the byproduct being lactic acid. So lactic acid levels in the muscles increase when high intensity exercise continues, beyond 10 seconds. If the lactic acid is not cleared from the muscle, it accumulates due to an insufficient amount of oxygen. Okay, we need oxygen to clear that lactic acid, and a lack of oxygen can lead to a lactic acid buildup. So this then results in the lactic acid building up and increases acidity. Okay, so if it's not clear from the muscles, it accumulates due to insufficient amount of oxygen, and obviously this includes acidity in your body. The inability to clear lactic acid from muscles results in the feeling of heavy legs, and I'm sure we've all gone through that. The best way to clear lactic acid is to provide them with oxygen, and to do that, that's through continuous aerobic activity, so low intensity exercises such as walking and jogging. That's why hopefully your coaches are not just finishing your training sessions and getting you to walk off or static stretch. You should be continuing some sort of light aerobic activity such as walking up and down the court or field, or doing some dynamic stretches. So how long does it take to clear or remove lactic acid? It can actually take up to an hour if cooling down with gentle exercise. Not many people know that. However, if you don't do any exercise, gentle exercise, it can take actually up to 2 or more hours. So a lot of lactic acid buildup, and if you don't do anything after your exercise, it actually takes longer to remove. So applying it to our touch football context, the lactic acid system provides the energy for all resynthesis of ATP during high-intensity, moderate duration activities lasting around 30 seconds to 2 minutes. Think of the touch football context. Those high-intensity, moderate duration activities that last around that time frame are probably things like a set of rucking or a set of defense. To summarize, again, take a screenshot of this summary of the lactic acid system. Method of energy production is anaerobic. It's rapid ATP production, however, it doesn't really produce a whole lot. Fuel source is glucose from carbohydrate breakdown. Limitations is obviously lactic acid buildup. Duration, intensity of around 85 to 95. So the creatine phosphate intensity is 95 to 100, is a little less. And any sort of activity that lasts between 30 seconds to 2 minutes. Again, girls, to finish, here's a quick video on the lactic acid system. So again, take some notes.
The lactic acid system can provide energy for longer than the ATP-CP system because it uses a more abundant fuel. That fuel is carbohydrate in the form of glucose. Glucose circulates in our bloodstream and is also stored in muscle and liver cells as glycogen. In the lactic acid system, glucose is broken down without oxygen to give energy for ATP resynthesis, plus the byproduct, lactic acid. As in the ATP-CP system, energy is produced quickly, but the buildup of lactic acid causes fatigue, which we feel as a burning sensation in the muscles. The more intense the exercise, the faster the onset of fatigue. This limits the contribution that the lactic acid system can make. So during intensive exercise, the lactic acid system dominates from about 10 seconds when the ATP-CP system is depleted, up to a maximum of about 3 minutes, depending on the intensity of exercise. In sports played over longer periods, the lactic acid system is important for supplying energy quickly during intensive phases of play.